So Cura is by Ultimaker. And I work on Windows, but they do have options for other type of systems. While Cura installs, I just want to kind of talk about the other two slicers that I use. So I have just decommissioned my Prussia. I'm thinking about recycling, trying to turn it into a recycler, or some of the parts at least. But so this is the slicer, the Prussia slicer. The one that I am currently using is Voxelmaker. And I've just started using this one, and I do feel like it's limited. So I was actually thinking about or planning on installing Cura myself. My first experience with Cura was at a job. I had a local packaging company needed they used a little in-house print shop to create some tooling, and they needed help creating, configuring the printers and getting them set up, and a specific model produced. And they used Cura. So that was my first introduction to Cura, and it's super easy to use, pretty intuitive. So let's see, we'll get in there, we'll start playing with some settings. Ultimaker Cura Get Started. Read everything you have to read. I'm a speed reader, so I did already. Create your account if you don't have any. Wait a minute, hold on. Let me go back. So I am not using an Ultimaker printer. So now we can sign in. Lab Aquila X2 is what I am currently using. It's still new to me, but so far so good. I'm enjoying it. I do think it is an upgrade from the Rep Prussia that I just kind of decommissioned. I definitely think this Voxelab is better quality than that. But to be fair, the Rep I had for years and years and years. And I also had it through I think it was 6 or 7 relocations. And I'm gonna tell you, my life was not totally together for all of those relocations, and so I'm sure it was not treated the best. I am not seeing my printer there, so I'm going to put in okay, so let's at the same time pull up my specs for my printer. Here we go. Here are our parameters. This one will fall in here. Out there. Okay, print size 220, 220, 250. So that is an X of 220, a Y of 220, and a Z of 250. Build plate rectangular. Origin at center, no. Heat bed. Heated bed, yes. Heated build volume, no. So this would require like an enclosure to maintain the area in which your thing is heated. I don't know that it says specifically, but I am pretty sure that my origin is this Well, I don't really, okay, so this is backwards, but I'm pretty sure the origin is the front corner of mine. So if this is the print bed, the screen would be over here. My origin would be over here. So I'm gonna leave that. Okay, cool. I am going to leave the rest of the printer settings. Let's go look at our extruder settings. Okay. Where do we have it? Nozzle diameter standard, 0.4 millimeters. Material diameter is this 1.75. Oops. Come on, man. We shouldn't have any type of offset. Okay, and then we'll go next. Next. In terms of, I kind of am going back a little bit. In terms of maybe it's the second to last one, and then I just said skim. And then I lost what I was gonna say. It started with in terms of in terms of nozzle diameter, so 0.4 is standard. If you went with a larger nozzle, you could print faster. If you went with a smaller nozzle, you could print more precisely. So it depends on what you're prioritizing there. Similar to layer thickness, but layer thickness you can change per print or even throughout your print. Whereas your nozzle diameter, you would have to change the actual part. I pretty much always work with a 0.4, other than if I'm freelancing or doing a service job or something. My own printer is always 0.4. So I want to kind of play around with something. A common like starting print for people to do, and it's one that I've been wanting to do because I do need coasters around my house, is to print coasters. And the reason that it's a cool early print job is because if we get rid of, so the way 3D printing works, right? There's your base layer. Your bottom layer is going to be pretty much a sheet, right? Full coverage of whatever area you need there to be coverage. And then as we build up, we're going to start having what we call infill, which is like the filler. It keeps the structure. It makes it so that we can build up and have overhangs, but it does have negative space in it so that we're not using a ton of material, 2, lighter parts, 3, faster prints, right? We don't want to, if everything was completely solid, all our prints would take forever. So I'm going to go into Fusion and I'm going to create a set of coasters. We'll look up coaster dimensions just so that I don't have to do it myself. Let's do that. Okay, so let's say 96 by 96, 95 by 96. I'm gonna go 96 by 96. This is also another thing about with the coasters is that if you print something, how would I say it? If you print something shorter, the shorter your print, the faster it's going to go, right? The height, adding height to 3D prints makes it last a lot longer. So, like, let's say, let me extrude this before I finish that thought. And I don't think we even need it. Let's do something in between. Let's do 7. Okay. You know what? Let's go back to the 10. Now I'm questioning myself. Okay, so 7 is definitely large, 10 is definitely large. Okay, so let's go with 5 because I do want you to get the texture of the infill. Okay. I want to go back into my sketch. I could have done this while I did the sketch originally, but I didn't. And I'm just gonna round out our corners just to soften things up a little bit. Finish. Okay. So let's do this one. Now I'm gonna name this square coaster. Okay, so let's set up a printer for me. I have the VoxLab Aquila X2, I believe it's called. This should have specs right here. Okay. So in terms of our printer settings, XYZ, that's our print size dimensions. And on mine, it'll be 220X, 220Y, and 250Z. Rectangular build plate is usually standard as well. And if the dimensions look like that, it is rectangular. Origin at center, no, I believe my origin is the front left. Heated bed, yes. Heated build volume, no, that would require an enclosure. Marlin is standard. For G-code flavor, Marlin is standard. If you have a printer by one of the other manufacturers or by a manufacturer listed in the dropdown, select that. And if you're unsure and you want to confirm, go ahead and check Google because somebody has definitely asked it in Reddit or some type of forum before. The gantry height is going to be your Z value. Find the gantry for you. That's that top piece. Okay. Offset to G-code extruder setting nozzle size 0.4 is standard. And that is what I always use at my home shop. If you wanted to, you could go with a bigger nozzle to print faster, or a smaller nozzle to print more, what's the word, more precisely. The downfall, the con is as you increase precision, you decrease pace, or speed of the print. And as you increase the speed of the print, you're going to decrease your quality. Like as the nozzle gets bigger, the layers are going to look more obvious and so on. Filament size, I think this is interesting, because 1.75 is a standard filament. So it's interested that it said that one. Okay. Next. That's next, yeah. Finish. Read all of that, of course. Speed read. Okay, so now let's see if we can get some things in here. There we go. Open files, downloads. Let's start with our square coaster. That is a huge coaster, isn't it? It feels large. I'm looking at the print bed. But I did look up dimensions, so I guess let's leave it, right? Let's leave it. Maybe let's just scale down a little bit. Number locked on. So uniform scaling will make it so that they all scale at the same rate, right? If your dimensions are important, obviously, don't scale it and definitely keep that locked on. Okay, so what we want to do with this, the reason this is a cool first one to do, let's go with a normal resolution. It's kind of like just a fun project. Yes, it's around the house so people will see it. So the infill percentage is how dense is that material on the inside? What the infill does, so if you were to have like a bridge, right? That can be really difficult. I think I even have you can get some overhanging and stuff. Let's go to our print failures. Printing. Overhang failure. Okay. So you can see that like it's not the best quality photos, but the filament is struggling to stay up where it needs to. Having infill supports the upper layers of filament. Some things, especially larger pieces, you can gradually increase infill as you get towards the top. So you're having slightly increasing amounts of overhang and increasing amounts of material in there. And so each layer, there's a little bit of overhang, which minimizes the risk of there being an overhang failure. Right, there's more material internally to support the external material. Support would be if there are overhangs that you could use supports that would break off to maintain those overhangs. Infill is more when you're working in a solid to prevent having to use maximum amount of material. Adhesion enable printing a brim or a raft that will improve your adhesion. It'll add a flat area under your object, which easily cuts off afterwards. The brim is, so a skirt will help if you have a finicky nozzle or if you tend to get clumps at the beginning of your extrusion. It just gives you more, like it gives the filament like a practice loop, right? The brim is going to help more so with adhesion. So I would say I use skirts for first level print quality improvement, or almost like a troubleshooting couple seconds into the print, whereas brims I'll use to help with adhesion. So something like this where it's tall and there's not a ton of surface area where the print is touching the print bed, it can make it likely that that print could break off, or it makes it more likely the print could break off as you're increasing the height and all that, and minimizing the contact there. So the brim is going to create additional contact there. It's usually one layer tall, and it just kind of goes around the base of your part. It's pretty easy to break off because it is just one layer. Goldilocks of adhesion assistance. A raft has more layers than a brim does. I just printed something with a raft recently and it was a nightmare to break off. I hated it. Okay, so we want to do normal. Everything else I'm going to pretty much leave, but what I want to do is play around with the infill. What we're going to do as well is we're going to get rid of these top layers. And what that's gonna do is you're not gonna have any solid layers covering the infill. So what that's gonna do is that's gonna leave your infill exposed, which is why it's such a fun, like, early project, because it gives you the opportunity to see what the infill looks like, how density affects infill. So depending your infill, you have an infill pattern. Let's put it to, it's gonna give us a preview, so that's gonna allow us to play around with our settings after and kind of see what it looks like. Oh no, what happened? Undo whatever I just did. Okay, I want this to be, let's go 15. We'll get to preview it. So let's start with a grid. And everything else I'm gonna leave, and I'm gonna hit slice. Make sure your material is right, obviously. Okay, so now we have sliced our part. I want to preview it. So it's saying it would take 1 hour and 19 minutes to print. That's because I do have a little bit of a, oh, it does have it has a brim on it. I don't think we need it in this case because it is a flat object with a lot of surface contact between the part and the print bed. So let's go back to our settings. Let's go support. No, build plate adhesion. None. Okay. It's also dependent on your material. So some materials are have more adhesion problems. Also depends on your print bed. But yeah, let's go. Okay. Let's turn this down as well. Let's go back to that original 10% and slice it. So what we should see now is that the grid, the internal grid. Let's see, how do we? These are our different views down at the left. Our internal grid has become less dense. So I am using middle button. So I use a mouse when I'm doing stuff like this. I'm pressing this scroll button and sliding the mouse to pan. And I am scrolling in and out to zoom out, in forward to zoom in. And then right click and move your mouse and that'll rotate you. Okay. But yeah, so here we should see a less dense infill. We got rid of that brim. It still seems long. I looked up coaster dimensions, but 2.5 inches. I hate inches. 82 millimeters. Okay, so we can shrink it down a little bit more. Not a ton, honestly. Let's do 87. Okay. And then I'm going to turn off uniform scaling now, and I'm going to decrease this. No. Stop it. I'm being impatient. Okay. So cubic subdivision is definitely one of my favorites. It has higher density towards the outside of the build, lower density towards the inside of the build, because of the way this coaster would be. The top is going to be surface level, that's going to be towards the outside. So we are going to see a consistent density in our build. But if you were to have a larger object, you could see more variation in that density. In the density of that object. You can maybe see a little bit of, yeah, not really. So if we're looking for strength, I would say probably go with triangles. Cubic is where you would want to go to find that medium between strength and speed of your print. It's what I use most often, and not that one though. Cubic or cubic subdivision. So cubic will be a constant cubic. So all of the cubes will be a consistent size. Whereas cubic subdivision, you're gonna have higher density towards the edges of your print. In this type of print, we probably won't see anything because it is everything's close to the surface in what we're seeing. But in larger prints, as you over here, this thing, it'll take you through the print layers. So this is what layer 1 will look like, 2, 3, so on. And here you start getting different colors for different, the colors stand for things. So our yellow is going to be our solid. It looks like red is the outer layer. Green is the inner core. Orange is our infill. This would be layer 7, layer 18, and so on. But so if you had a bigger print, you would be able to see it. If you want to prioritize speed, lines would be a good one to do. What we can do for this infill coaster project then, now that we have the top layer removed, we can set up infills that we think look interesting, that we want to kind of learn what their pattern are. Set that as the infill for this print, export our print, slice it, then export it to your, in my case it's to an SD card. You may connect directly to a printer, but I export it to an SD card and then I go run my prints. Thanks for watching. Don't forget to hit that subscribe button to stay updated on our latest videos. And if you're interested in our services, head on over to our website to learn more about our expertise in 3D printing, maintenance, reliability, asset management, engineering, drawing, and design. See you in the next video.